I'm Mr. Nix, and I'm back for round two of what will be 3 rounds of this extended lecture as per the work you've done. And the first lecture, of course, was devoted to characteristics of man as an animal and the numerous adaptive complexes that humans have acquired and share with some other animals too over the course of millions of years of evolution. And hopefully that made some sense to you. And we're going to pick up now with part two, which is the second text reading before history and the evolution of man, humans, in a nutshell here. So I'm going to go through another 16 or 17 slides for you. And once again, this is all going to lead to a test. So the idea here is to listen to the lecture, look at the slides, and in the end, I'll send you the slides too, for you to match up with what you've already done and to fill in the gaps and to connect the dots and to flesh things out as per my lecture, because the test itself will be predicated largely on the lecture. I mean, in other words, there's the text work that you've done, and then there's this. Okay. Before we get into this image here and the slides that follow, let me take you back 2 slides here to focus once again on this, because there's something I left out in the previous screencast lecture, which is really important. Talked about culture and talked about adaptive complexes and talked about evolution and talked about the brain and talked about a reproductive economy and all the other adaptive complexes, but I failed to really kind of bridge a gap here, and it has to do with Clifford Geertz, who was quoted in the first reading, Characteristics of Man as an Animal, talking about the connection between humans, human evolution, these adaptive complexes, and the development of culture, because after all, humans are the most cultural beings on Earth. And there's a pretty profound line in there that sticks out in that reading where he says, without culture, let me back it up here. Without man, no culture, yes, but without culture, no man. And that's a really key line there, because it kind of gives us a lot to go on. On the one hand, without humans, okay, without man, no culture, right? In other words, if you don't have human beings, you're not going to have any cultural expression. You're not going to have language. You're not going to have clothing. You're not going to have the kind of foods we eat. You're not going to have all the things that we chalk up as culture, all that extra genetic transmission of information, i.e. learned behavior. But what about the other side of that? What about the idea of without culture, no man? Okay, and basically what Clifford Geertz is getting at here is something I did allude to before in the previous screencast, and that is that as humans, and because of these adaptive complexes, because we're a migratory species, and because of our reproductive economy, and because essentially as a species we are not adapted to any particular environment, that is, we can learn to live in any environment, we are born unspecialized. That is Cope's law of the survival of the unspecialized. And in other words, we're not born precocious. We're not born ready for the environment in which we're introduced to. We have to learn everything. Okay, and that's the idea. And so there's a huge gap between what we come into the world with in terms of our instincts and what we need to learn in order to survive in that environment. And that gap there is culture. Okay, once again, the extra genetic, that's key, right? Extra genetic transmission of information. And that's why I'm hip on this particular slide, because it shows that transference of culture, that transference of the extra genetic transmission of information is going on between mother and infant in this slide. So once again, without man, no culture, right? Because humans are cultural beings. But on the other side of that, without culture, no man. You strip culture away from humans, and we are unworkable monstrosities. We're humans biologically, of course, but we're not humans in any sense of the word otherwise that we might associate with that. Okay, I hope you got that. We should move on to the second part of this, and it has to do with this picture here. This is a representation of Lucy. You read about Lucy in the second reading, before history, the text reading. And you know that she lived about 3.2 million years ago. She was discovered in 1974. And the reason why she is named Lucy is because at the time of her finding in 1974, the song on the radio was Lucy in the Sky with Diamonds. So goes the story. It's a Beatles song, okay? And so the researchers who discovered her fossils decided to name her Lucy. And she's not the oldest human fossil. She's not the oldest hominin human fossil. Actually, the record goes back about 7 million years, as I maintained in the first screencast lecture. But at the time of her finding, she was the most complete. Okay, so she really rich trove of fossil record in terms of early humans. And the idea is, well, now that we have Lucy and her kind, which I'll get into in a minute, how did they live? What made them human? And all that stuff. And that's what we're going to get ready to talk about. Okay, and some of this, once again, or a lot of this dovetails with what you've already done, but I'm going to try to add some things along the way, so please pay attention. Okay. Once again, humans, we're animals, we're mammals, we're primates, we're hominins. And in the first screencast lecture, I talked about the difference between hominins and hominids and how they overlap. Humans, yes, are also hominids because we share DNA with the great apes and at one point had a common ancestor from which we both diverged. So we are both hominids in the sense that we are part of the great ape family, but we're hominin in terms of the fact that we're human. Okay, so you can kind of read this here. I'd take a look at this if I were you. I don't want to read it to you, but just a couple images, or at least one image I thought was really cool. Notice before I said that Lucy is not the oldest hominin human fossil in the record. It goes back 7 million years. Another really good find that came out, I don't know, maybe 6, 7, 8 years ago, was a being now known as Artie, okay, or Ardipithecus aramidus, as you see here. Smaller than Lucy, smaller head than Lucy, smaller brain than Lucy, more ape-like than Lucy, but still a hominin, still a human, okay? And so part of our ancestors, okay? No longer around, extinct, of course, but you can see here if you're looking at this skeleton, and if nobody said anything to you and you just kind of looked at the skeleton, you might say, wow, it looks kind of like an ape. And in fact, Ardipithecus was very ape-like. Okay, the hands, the feet, the shortness of the limbs. Okay, the the lowering of the head, that is the shortness of the neck. All of those are sort of ape-like qualities, but nonetheless, it's considered to be a hominin, a human, but still getting back closer to that point in time when humans and apes diverged from a common ancestor. And this just shows down here. For some reason, I can't get my cursor going here, so just kind of look at it with me if you could. There's Artie, and there's Lucy. There's a chimpanzee, and there's modern humans. That's you and I. All right, so we're on the same page here. Now, Ardipithecus had quite the small brain, okay, about 355 cubic centimeters in terms of volume. Slightly smaller than Lucy's and much smaller than ours. Okay, and a lot of this in terms of human evolution is basically a story of brain growth and bipedalism, which we're going to talk about by and by. Okay, you've seen this already. This is just to kind of remind you in terms of the hominin break and the evolutionary break when it comes to a common ancestor and the divergence of the line of great apes and then the line of hominins or humans. Once again, there's the fossil record that stretches us back almost 7 million years. And you can see these various beings along the way. Now we're going to talk about some of these today. We're going to talk about Australopithecus, that would be Lucy. We're going to talk about Homo erectus. We're going to talk about Neanderthals, and we're going to talk about Homo sapiens. That's us. Okay, so stay tuned. You might want to take a screenshot of this because this really sums up the entire chapter. And if you can answer all of these questions, you are in really good shape for the test. So I would take a look at this. I would take a screenshot of this, and I would kind of go over it. And as the lecture unfolds, these questions will be answered. Okay, we'll go over them, or I'll go over them. One thing really quickly up front, if you look at number 1 there, what is the difference between Paleolithic and Neolithic eras? This is something that you wrote about when you read the chapter reading, okay, before history. Really, to make it simple, I'm going to just kind of break it down for you. Paleolithic means Old Stone Age, and it speaks to the kinds of tools that humans used for most of human history to the extent that we were tool users. We'll talk more about tools in a few minutes. So Paleolithic era is really a good chunk of human evolutionary history over time that is characterized by the use of stone tools and the improvement in terms of those stone tools over time. So you'll see that once again, the kind of tools that Lucy used weren't as good as the kind of tools that Homo erectus used, which weren't as good as the kind of tools that Neanderthals used, which weren't as good as the kind of tools that Homo sapiens eventually began to use. All right, so Paleolithic, Old Stone Age. Now, Neolithic, it's a bit of a misnomer actually, because it means New Stone Age. And yes, the tools were better, no doubt about that. But really, the defining feature of the Neolithic era, which begins around 12,000 years ago. Okay, so everything before 12,000, roughly speaking, is the Paleolithic era. And then from about 10,000 BC or BCE, about 12,000 years ago going forward, we entered in what's called the Neolithic era. And once again, Neolithic, just like Paleolithic, Neolithic means New Stone Age. But it really isn't marked by a sudden shift to better tools, although that was part of the process. The defining feature of the Neolithic era is farming. Okay, the idea of the domestication of plants and animals. That's why they call it sometimes the Neolithic Revolution. Okay, it wasn't a revolution in the sense that it happened overnight, but it did happen over time, and it was changing in terms of, or I should say, it was had a big impact on human existence, because once humans began to domesticate plants and animals, going from hunter and gatherers during the Paleolithic era, slowly but surely into becoming farmers and settled peoples and domestication of fruits and or vegetables and plants and animals, humans enter into a new era. Okay, and we're going to talk about that later. That'll be the third screencast lecture. So hang in there. So once you've taken a shot of this, and we start to answer these, we'll continue on. And there's Lucy. Okay, well, that's what we think she might have looked like. There you can see that she lived about 3.2 million years ago, but her kind goes further back than that, and you would have read about that in your reading before history. Okay, in fact, Australopithecus goes back, I don't know, some 7 million years. Okay, and overlapping with some other species of humans that were around at that time. And one of the things I want to do here is to go through each of the various human forms, beginning with Lucy, Australopithecus afarensis, and talking about some of their characteristics. Okay, what made Lucy Lucy? What made Australopithecus unique? Okay, so that's what we're going to talk about in a few minutes. What this map shows here is basically where all these finds are. Not all of them, by the way. I'm going to show you another image in a second that's going to kind of contrast that or undermine what I just said. But if you go to East Africa and what is today Ethiopia, Kenya, and Tanzania, what's called the Great Rift Valley, this is where some of the earliest human fossils are found. This is where humans develop. This is where humans evolve. So there's something going on in East Africa millions of years ago to produce evolutionary changes in what eventually becomes the human being, okay, the hominin, right? What are those factors? Well, most likely it's just the perfect spot in terms of the climate, in terms of the environment, in terms of the availability of game, the availability of natural resources such as they were exploited by early humans, like water, okay, food and water, that allowed for the humans to develop. And one theory out there is that, climate change changed the landscape of East Africa, and it became less forest-y, less perhaps rainforest, and became more savanna. And with the disappearance of trees and the opening of the savanna areas, this forced a genetic adaptation and evolutionary change that allowed humans, if you will, to come down from the trees and to begin to emerge as bipedal beings, and all the other changes that kind of came along with that. A lot of that speculation. Nonetheless, this is a great spot here, and this is where humans developed. And there's a bit of controversy about that today, because South Africa, we know, also has a lot of early human fossils. And South Africa is making the claim that it is the cradle of humankind. And I'm not going to get into that debate right now. Suffice it to say that East Africa and the Great Rift Valley, and what is today Ethiopia, Kenya, and Tanzania, and South Africa, and what is today South Africa, are the areas where we find the oldest human remains. Okay, so there's something going on in Africa. Cool place, right? All right, here's Australopithecus. Here's Lucy. Okay, and I was a little wrong before. I said 7 million years ago. I think the fossil record has been pushed back. But why don't we go with the dates the text gives you and what's on here, and the idea that Australopithecus lived for about 1.15 million years. That's pretty good, right? Because Homo sapiens, us, have only been around about 300,000 years, and the modern human that you and I are related to has only been around about 40, 45, maybe 50,000 years. Okay, so these early human forms, they survived a long time. They did pretty good for themselves. Okay, what are the characteristics of Lucy? What are the characteristics of Australopithecus? Okay, well, you read in the text that she was about 3.5 feet high, although an earlier image I showed her to be a little taller than that. Okay, so let's just go with the text on that one because you have that information in front of you. She weighed about 55 pounds. Her brain was about the size of a grapefruit at roughly 500 cubic centimeters in volume, which is a little bit more than 1/3 our size. Okay, and of course we have bigger brains than Lucy, so you get the idea. We talked a lot about brains in the last screencast. Okay, Lucy's diet was varied. She was an omnivore. She was omnivorous. Okay, and she ate meat. That's a key thing to understand. in terms of human development, something I'll talk about later when we talk about fire. But there you have it in terms of Lucy. Okay, small, very ape-like. In fact, the name Australopithecus literally translates to southern ape, but she wasn't an ape. She wasn't part of the great apes. She's a hominin. She is a human. Hominid, yes, because they're all connected, but hominin in terms of the fact that she is an ancestor of ours, extinct, but still part of the human family tree. Okay, moving on, this is just a nice little image here showing what Lucy's fossils looked like. And what's there in yellow, I guess you would say, those are the fossils that have been found. Okay, so a almost complete form here in terms of the fossil record, and it just shows what she looked like. And once again, very broad shoulders, very short neck, very ape-like in appearance, a large pelvic region, short legs, okay, long elongated forelimbs and long fingers with kind of an opposable thumb, but not quite as good as ours. Okay, feet that are meant for not only perambulation in terms of being bipedal, but also for climbing trees. So the idea is that Lucy might have been sort of in a transition period where she spent some time on the ground, if you will, walking around bipedally, but also going up in trees as well. So somewhere between perhaps ape and human, but definitely human. Okay, that's key. These are the tools of Australopithecus. These are the tools of Lucy. Okay, a tool making, tool using being. So definitely a sign of intelligence there. Humans aren't the only animals that use tools. We've seen gorillas use tools as well, but not make them in the sense that this is obviously something that's been honed to be usable as a tool. Simple choppers, simple scrapers. Okay, these are rocks that have been honed by humans to perform their tasks. And basically, what the tasks are is the procurement of meat. Okay, butchering meat. Okay, cutting bone, getting at the marrow of the bone, so that these Australopithecus people, if you will, can eat. Okay, now was Lucy a hunter and gatherer? I mean, that's kind of what she's painted as. The extent to which he hunted is unknown because it takes organization. It takes a certain level of intelligence that she may not have possessed in terms of what it means to be a human. But certainly she was a scavenger and would have found meat around killed by other predator animals, and would have used that meat for the purpose of the diet. And these tools are meant not for hunting per se, but for simply butchering meat and butchering bone, if you will, cutting up bone to get to the marrow. Okay, so these are the tools of the Australopithecus, simple choppers and scrapers, but definitely pretty good when you think about it. Okay, one of the big issues out there, or controversies out there, or questions out there is, to what extent did Lucy possess language and speech? Okay, and basically there are two, anatomical pieces of evidence that point to the ability for speech, for language. One is the hyoid bone, which you're looking at right here, which is a small bone that's in the throat area that's used to hold up the larynx and the vocal mechanism. So if you don't have a hyoid bone, you're not capable of speech because your larynx won't be able to produce the sounds and be positioned properly for that. The other anatomical evidence for language would be brain size. And of course, the idea is, did a being like Lucy, whose brain was 2/3 smaller than ours, have the ability for language and speech? And I think most people might say that she did, only because they were pretty sophisticated in terms of their ability to procure food, and that's also pretty much a sign, not anatomical, but certainly in terms of the fossil record and the record of these people and how they lived, might point to the use of speech. Okay, by the time we get to Homo erectus and those beings, speech is probably definitive. Okay, but speech and language, of course, is a huge thing when it comes to human evolution, and I spoke about that in the previous screencast lecture. This is just showing the idea of bipedalism. Up top there is a depiction of Lucy. If you looked at that really quickly, you'd simply say, "Oh, there's a nice monkey. There's a chimp there. There's an ape. There's a gorilla, whatever." No, that's Lucy. That's a hominin. That is Australopithecus, who's eating fruits and nuts that could be gathered from the environment in which she lived, okay, or they lived. And bipedal, yes, but maintaining very ape-like characteristics and the potential for tree dwelling as well. By the time we get to Homo ergaster, okay, who lived about 1.6 million years ago. We're talking about a being that is very bipedal, very much up on the run there, and that's what this image is supposed to connote. Now, with regard to Homo ergaster, okay, you don't really care about this, but some records, or I should say, some scholarship shows that Homo ergaster and Homo erectus are pretty much the same thing. Okay, and we're going to talk about Homo erectus in a minute. But at the risk of confusing you, some say Homo ergaster is separate from Homo erectus. Others say Homo ergaster should be categorized as Homo erectus. Okay, I'll let the jury figure that out some other time. The only point I'm trying to make here is that as you move through evolution, these human forms are becoming more bipedal. And in fact, it's going to be Homo erectus and maybe even Homo ergaster, if they're one and the same, are the first who are going to migrate out of Africa. Okay, so fully bipedal beings are going to do that. And I'll show you a skeleton comparison in a few minutes. Okay, on to Homo erectus, man who is upright. Okay, so Australopithecus means southern ape, but of course Lucy was not an ape. Lucy was a hominid. Lucy was a human. And Homo erectus, who lived in these dates here that you can see very successful, living almost 2 million years in terms of the fossil record as we know, is going to be an improvement upon the human form. Right? So everything we talk about now in terms of characteristics of is just kind of bigger and better. Okay, you can see that the brain volume is twice the size of Lucy's. Okay, and about 2/3 the size of ours. So we're getting into a more intelligent being. Homo erectus, by virtue of what it means, man who is upright, is going to be fully bipedal. Homo erectus is going to be the first to migrate out of Africa. Homo erectus definitely had speech capabilities and language capabilities. And Homo erectus is going to be the first that we know of for a fact who's going to control fire, which I will talk about in the next screencast lecture. There's a lot to talk about when it comes to fire. Okay. Other characteristics of Homo erectus, we see right there, larger brain, okay, migrated, definitely fire, definitely language, okay, and used better tools. And I'll talk more about tools next time. I'm not going to get into the Homo erectus toolkit right now. You can look that up in the reading that you did, but I will flesh that out in the next screencast lecture just because of the order of the slides. And I want to break this up because I don't want to spend another 50 minutes on this, and I'm sure you're cool with that as well. So there's Homo erectus. If you can compare Homo erectus to Australopithecus, it looks like this. Now, this is drawn to scale in the sense that Homo erectus was bigger than Australopithecus. Homo erectus was bigger than Lucy. This is just showing a side-by-side comparison so you can check out why Homo erectus is different and how Homo erectus is different and why we would say Homo erectus looks more human than does Lucy. And what we have here is a smaller head, better balanced on a longer neck, more narrow shoulders, a more narrow rib cage, okay, a thinner or more slender pelvic region, okay, a larger gluteus maximus, which is key to bipedalism. Remember, Australopithecus was bipedal, but she also spent some time kind of climbing trees. So you might mistake Lucy for being an ape, as of course her name implies anyway. You can see that the femur muscles, the leg muscles, the bones are longer, okay, and straighter, and the foot arches are more stabilized for walking. And that's what Homo erectus is, a walker, an endurance runner. And by the way, I might have said this before, but humans are made to walk. We are the best walkers and endurance runners of any animal on Earth. We may not be the fastest for sure, but we can run the longest, okay? And it's not just because we're bipedal. It also has to do with how we cool our bodies through our skin. Okay? We're not panting. We've lost our hair. We sweat through sweat glands on the skin, which is a very efficient way of cooling your body, particularly if you're covering long distances, which humans were as they hunted and migrated out of Africa. And remember, once again, Homo erectus is the first to migrate out of Africa. So Homo erectus has got a lot going on for it. And I think this image here really, in comparison to Australopithecus, gives us a lot to go on. So there are some characteristics of Homo erectus. At this point, we've talked about a couple of things. One is, what is Australopithecus? The find of Lucy and why that was such a big deal. What were the characteristics of Australopithecus. Why is Australopithecus a misnomer in terms of the fact that Lucy was not an ape and her kind were hominins? And then we moved on to Homo erectus, not necessarily the next in terms of human evolution, but this is how the text deals with it, and we're going to keep it simple. And Homo erectus, of course, means man who is upright, and that kind of tells you everything you need to know, because here's a being that was fully bipedal and looked very human-like compared to Australopithecus, and has all the sort of bone structures that are necessary for bipedalism, including a very large gluteus maximus, which you're going to see in a few minutes when I show you this cool video on human evolution, so stay tuned for that. And Homo erectus would be the first to migrate out of Africa. I've said that a number of times. Definitely had speech, had a hyoid bone, of course, had a larger brain, better tools, better organizational skills, okay, better planning skills, and controlled fire. I think I said that already, so let's move on. Speaking of the video, okay, once again, bipedalism, which is a great mark of human evolution. And that's just showing you a fully bipedal modern human versus a modern chimp who's a quadruped. Now, let's see if I can get this video going without my cursor. There it is. So this is about 9 minutes. Stay with me.
An extraordinary piece of engineering, honed over millions of years.
Let me start over here, guys, because I want to just fast forward to a spot. Skip about a minute.
First bipedal apes.
Back it up, Mr. Nix. You're getting ahead of yourselves. I should have just let it run, right? There we go. Yeah.
Of the evolution of us.
No, you can't win here. Just let it ride. Go ahead.
The human body is an extraordinary piece of engineering, honed over millions of years of evolution. With our upright stance and our large brains, we evolved to become the primate that rules the planet. It took a scientific revolution to understand who and what we are, to uncover clues hidden deep in our DNA, which explain how we got here, and crack our genetic code to see where we are going. This is a story of epic proportions, and it tells the tale of the evolution of us. Africa is where the human story begins. Today, the vast grasslands of the south are home to the Khoisan people. These Khoisan hunters may seem like supreme athletes, but most of their genes are shared by all of us. The human body is a magnificent machine, tuned over millions of years. The genes inside each of us date back to our most ancient ancestors, the first humans to walk the earth.
We have this incredible adaptation for walking on two legs, and that seems to be quite fundamental. And that seems to have evolved quite early in human evolution, certainly more than 4 million years ago.
Walking upright is a defining human characteristic. If scientists can understand how and why this happened, then they will have solved a big part of the evolutionary story. Upright walking led to a series of other genetic changes affecting our bodies and our behavior. But how did it enable us to become the primate that rules the planet? At Kyoto University in Japan, Professor Aishi Hirosaki wants to know how walking on two legs might have affected the bodies of the earliest humans. He studies what happens when macaque monkeys stand on two legs and walk.
I wanted to know how human beings changed their way of moving to walking upright. To study this, I needed an animal that normally walks on four legs, but is capable of walking upright. So I decided to use a macaque monkey.
Because the macaque monkey usually walks on all fours, his attempts to stand upright are among the closest the scientists can get to the actions of our ancient ancestors, the first bipedal apes. The researchers use a pressurized mat to monitor the points where the monkey's foot hits the floor. The results show how the pressure changes from four-legged to bipedal walking, and highlights what else was needed for the earliest humans to walk on two legs.
The most important role of the hip muscles shifted to stabilizing the upper body. Chimps and other apes don't need to do that because they use four legs. But for humans to walk on two legs, it's essential to have muscles that stabilize the upper body.
Great mobility was something that would give our ancestors a giant leap forward. Throughout its history, our planet has been in constant flux. All species are forced to evolve by the never-ending changes in the world around them. Once they could walk on two legs, our ancestors continued to adapt quickly to changing environments.
Starting around 2.8 million years ago, Africa became a lot cooler and more dry. And that created an expansion of grassland habitats. So lots of animals that eat grass, the herbivores, evolved at that time. So there was selection for running 2 million years ago in order to become hunters.
Daniel Lieberman is professor of human evolutionary biology at Harvard University. He studies what needed to change to enable our ancestors to run.
If you ever look at the gluteus maximus of chimpanzees, for example, they're pretty small. But in humans, it's the largest muscle in the body. It's big. And we've done an experiment a few years ago where we showed that when you run, your trunk wants to pitch forward. But the gluteus maximus fires and pulls you back, keeps you from falling over.
Evidence in the fossil record reveals just how good our ancestors became at running.
This is a part of the skeleton of Homo erectus, who lived around 1.5 million years ago. And what's intriguing is that many of the features of the skeleton tell us he was a runner. For example, his pelvis has a very large area for the insertion of the gluteus maximus. We can look at the anatomy of his inner ear, which tells us he had a head that was really very well designed for sensing pitching forces. So he was able to keep his head very still when he ran. He had very large joints for the size of his body, much larger than you need if you're walking.
These changes to the skeleton took place over thousands and thousands of years. They led to the remarkable modern human body we know today. The truth is, we are all built for running, and to have the endurance to cover the long distances that are needed to hunt.
We walk and walk to find signs of animals. The way we hunt is to just keep chasing them. When the animal gets tired, we shoot an arrow made of bones, and then we catch them.
Walking upright and jogging and running, you can cover long distances very efficiently. So the prey will tire out, the prey will overheat, and it will actually slow down and eventually drop down with exhaustion. So this requires incredible marathon running ability to do that over long distances under quite hot conditions. And yet modern hunter-gatherers can do it in Africa, and our ancestors were doing it probably 1.5 million years ago. When you can walk upright, it's a great advantage. Your arms are free to carry things, to carry children. And tool making and tool using is fundamental to humans, and that may have driven the growth of the brain. Also, of course, once humans had the ability to make fire at will, this is very useful for cooking, and also it's a social focus.
All of these extraordinary changes came about thanks to tiny differences in our genes. But it wasn't until the dawn of the 21st century that we could truly explain the genetics of evolution.
Okay, we'll stop it there. Suddenly my cursor is back. That does a great job of encapsulating in about almost 10 minutes everything I've tried to say up to this point in more articulate fashion. And kind of back me up there, because I talked about the Great Rift Valley and the development of the early humans going back millions of years, and it seems that as East Africa cooled and the grasslands spread and the herbivores evolved for those grasslands, humans evolved to hunt those herbivores, all right? And that involved the eventual transition to full-on bipedalism, okay, walking upright, which also I spoke about in the first screencast lecture. It freed the hands, the forelimbs, to develop along different lines as opposed to being used for, perambulation, for locomotion. And as those hands are freed, they become more sensitive, and they are used now to manipulate objects and to eventually make tools, which is going to result in this positive biofeedback loop in terms of the hand-brain evolution. And that's pretty cool stuff, okay? I want to point out one thing. Those of you who are runners, you know this. Those of you who are not runners, well, you know what? You are, because you're built for it, which is pretty cool. I never really thought about this until I taught about this. But I want to kind of share a quick story with you just to illustrate the extent to which humans are able to run. And you guys can look at this stuff up on your own, and you probably even have your own examples of this sort of ultra marathon type running that we talk about, where people will run like 200 miles over the course of several days. But my favorite is the Big Backyard, which takes place every year in Tennessee. And this guy who has a farm down there and has some land simply kind of came up with this on his own. He's not a runner. I think he's a smoker and a drinker, by the way. But he decided he was going to come up with a race that would attract people from around the country, and one of extremes. And he just charted or developed a course that's a mile loop on his property. And so it begins and starts at the same spot. And the idea is that you sign up for this and you go down there, and basically it's a survival of the fittest. The last man standing is the one, or woman for that matter, is the one who wins the race. And it's pretty simple, actually, brutal, actually. You start and you have the mile loop that you have to run, and you get a half an hour to finish that mile, which is really a piece of cake. You could walk easily a mile in a half an hour, and anybody, of course, who's a cross-country runner would laugh at that. In half an hour to finish a mile. Okay, you guys are doing 17, 18 minute 5Ks. Okay, so think about that for a second. But it keeps going, and it starts every half hour on the half hour, and you have to get to that starting line and do the loop again. And of course, after many loops, you begin to tire, and it takes you longer to do that loop. And sometimes it might take you 10 minutes, and then it might take you 15 minutes, and it might take you 20 minutes. It doesn't matter. The point being is when it's time to start the loop again after the half hour, you have to show up at the starting line. And the race isn't over until there's one person left who finishes the last loop. So you literally have people who are coming in after a day and a half, 2 days, 3 days of lining up every half hour to run that loop, who might be getting 15 seconds of sleep and trying to shove down whatever food they can before the starting point again on that next half hour and lining up and running. And basically after about 3.5 days, 4 days, someone emerges as the winner. It's pretty crazy stuff. Anyway, we move on. Last slide for today, and then I'm going to break this off and continue with the third screencast lecture. And this has to do, once again, with bipedalism and the other changes that came about that I mentioned and that the film mentioned. And this just shows a comparison between Australopithecus, Lucy, Homo erectus, and us. And as we... Sorry about that, guys. That's COVID speaking, the COVID voice coming out. Bear with me. But as we evolve over millions of years and become more human-like and more intelligent and more upright, the pelvic inlet and the pelvic region begins to narrow. And of course, the brain begins to grow and the head begins to grow. So these are just anatomical changes that happen in accordance with bipedalism. And if you go from Lucy to Homo erectus to Homo sapiens, you can see that with increased bipedalism, you have a narrowing of the pelvic region, but also an enlargement of the pelvic region because the head is getting bigger because the brain is getting bigger. Okay, and now, of course, Homo sapiens have extraordinary large heads and large brains in terms of the overall size of the body. I talked about that in the last screencast lecture. Okay, so we talked about a lot today in terms of the evolution of human beings. We talked about hominins and hominids again. We talked about Lucy and Australopithecus, and we talked about Homo erectus, and we talked about bipedalism, and we talked a little bit about tools, but we're not done with that because we have to look at the Homo erectus toolkit. We have to look at Homo erectus migratory patterns. We have to look at the concept of fire. And eventually, when we get to Homo sapiens, the concept of cave art and perhaps even religion. So a lot of good stuff to come, but I'm going to leave it at that for now. I will say this one last thing, which is really off topic, but before I forget to talk about it, I've been home, obviously, for a week now. I've had plenty of time on my hands. Been watching some TV. Okay, I'm not a big TV watcher, but I happened to get onto the Disney Channel to watch the new documentary on the Beatles' making of the Let It Be album that came out in 1970, although the recordings for that in the studio took place in January of 1969. And those of you who are familiar with, I don't know, the guy Peter Jackson, who directed a bunch of films. Now I'm forgetting what those films are. They're quite famous, but I don't remember. It's not Game of Thrones, of course. Lord of the Rings. There you have it. Anyway, Peter Jackson is a Brit dude. He's a huge Beatles fan. Basically went through 60 hours of film footage from the Get Back, Let It Be recording sessions in January of 1969. And anybody who's into music, whether you're a Beatles fan or not, doesn't matter. Certainly your parents probably are. If you want to see geniuses in a studio making incredible music, it's definitely for you. It's 7 hours long, right? But if you got some time on your hand like I do, you might be worth it. All right, I'm going to leave you with that. Enjoy this screencast lecture. Study the information. The test is coming. Hope to see you soon.